Problem 9.44. Write the Lewis structure for the following molecules and ions. OF2, N2F2, Si2H6, OH negative, CH2Cl, COO negative, and CH3 and H3 plus. To write a Lewis structure, what you want to do is write down the symbols for each of the elements in your molecule. In this case, we have OF2. So we're going to have 2 fluorine. Is it fluorine? Yes, fluorine. Your oxygen and your other fluorine. The next step is to draw the valence electrons for each element. So for fluorine, you're going to have 7. So you have, and these are represented as dots. So you have 2, 4, 6, 7. Oxygen has 6. So you have 2, 4, 6. And your other 7 for fluorine. Okay, next step, as you see, you have 2 electrons that are right next to each other. So since it's a molecule, it means that they're all connected. So you end up with fluorine. But instead of having this one on its own, you're going to have a line. This line represents these 2 electrons. And it also represents how they're connected. So you have your remaining valence electrons. Same thing here. Have your line representing your 2 electrons and the rest of your valence electrons for fluorine. This is the Lewis structure for OF2. For N2F2, same process. You write down the symbol for each of your elements in the molecule. So you have 2 fluorines, 2 nitrogens. You draw your valence electrons. 7 for fluorine. 5 for nitrogen. And fluorine. Just like I explained above, these 2 are attracting each other, so they're connected. So this becomes that line. Right here, since you have 2 on each side, you have 2 lines instead of 1. So in here, you have 4 electrons. So right here with your fluorine, you have your 6, 7, and then your nitrogen has 2, 4, 5. Same with these. So that's the Lewis structure for N2F2. Now for Si2H6. Same process. You have 2 Si and 6 hydrogen. Hydrogen only has 1 valence electron. So you draw these first. And Si has 4. Erase anything? No. So same thing as before. These are all attracting each other, so they become lines instead of 2 electrons. So you end up with the 4 valence electrons for Si and each valence electron for hydrogen. That's your Lewis structure for Si2H6. For OH minus, same process. You draw your symbols and your valence electrons. Oxygen has 6. Hydrogen has 1. So this turns into this. But since we have a negative, you have to add another electron so that it becomes negatively charged. So your oxygen ends up looking like if it has 7 valence electrons. 6 and then plus this one, and hydrogen has its own valence electron. So that's your Lewis structure for OH minus. For CH2, ClCOO minus, don't forget the charge. You have the same thing. Draw your symbols. You have 2 hydrogens, 2 carbons, 2 oxygens, and 1 chloride. Hydrogen has 1, carbon has 4. And chlorine has 7. And it's negatively charged, so again, you have an extra electron. But first, draw all the valence electrons, don't forget. That's your extra electron. That makes it negatively charged. So instead of having the 2 dots, they turn into lines. So you have this. Right here, instead of having it on the bottom, we're going to move it right here. So you're going to have 2 lines. Here you have 1. And your other electron over here. And that's it. It's a little bit messy, but you have your 4 valence electrons for carbon, for each one for hydrogen, 7 for chlorine, and right here there's one of them, 4 for carbon, 6 for oxygen, and again 6 for oxygen, but you also have an extra electron because it's negatively charged. So that's your Lewis structure for CH2ClCOO negative. For the last one, CH3NH3 plus. Same thing, you draw the symbols of your elements. 1 carbon, 3 hydrogens, 1 nitrogen, 3 hydrogens. Yeah, 1 per hydrogen. Draw your valence electrons as dots first to make it easier. Carbon has 4. Nitrogen has 5. Okay, so then this turns out to be with the lines instead of the dots now, since they're attracting each other and they connect, in other words. Nitrogen has 5, so we put them on the side. So hydrogen has 1, so it connects. So there you have 1, 2, 3, 5, and your plus charge.